Now you might have seen these abbreviations in videos about the navigation display. This shows the top of descent point in regards to the entered flight plan in the FMGS on Airbus models or on the FMS on the Boeing. Now, as you see on the PFD and ND, we're at 27,000 feet with a speed of 320 knots. So with that data, we want to calculate the distance we need to fly a continuous descent profile. So we're going to cross out the last digits and divide that by 3. So 270 divided by 3 equals 90. So 90 nautical miles is the minimum distance we'll need for our descent. Now the next factor to consider is speed, as there is no way that we'll be landing the plane at 320 knots. Speaking of vertical speed, there is another technique you can apply. Now we'll use 200 knots as an average descent speed as mentioned previously. So we've determined the distance needed of 104 nautical miles. So for easier calculations, let's say 100 nautical miles. That means you need 30 minutes for the entire distance. 27,000 feet divided by 30 minutes equals 900 feet per minute, which should be your average vertical speed. In the rarest cases, the vertical profile is a 3-degree glide slope from top to bottom, as it is sheer impossible to maintain that slope and reduce speed at the same time. So commonly, pilots start off with a high-speed descent at 3 degrees or steeper. Now just before reaching 10,000 feet, you dial down the speed, the plane pitches upwards, creating a shallower descent path equal to 1,000 feet per 5 nautical miles. Now once you receive further descent clearance, you rejoin the 3-degree angle equal to 1,000 feet vertically, needing 3 nautical miles horizontally. Maintain 250 knots until reaching 5,000 feet, dial down the speed even more so you can extend the slats and flaps to establish yourself on the ILS, VOR approach, etc. So your vertical profile is going to look something similar to this. Now once established on the approach, another thumb rule: ground speed times 5 gives you the necessary vertical speed feet per minute you want to be flying to maintain on the 3-degree glide slope.